I'm analyzing data using the K-means algorithm, a popular method for grouping similar data points together. It's like sorting laundry. K-means finds the best way to separate different types of clothes, data points, into separate piles, clusters. I have a dataset with 1,000 individual data points. Each data point is described by 5 different characteristics, or features. Think of it like describing a person with their height, weight, age, shoe size, and hair color. Each person is a data point, and those characteristics are features. I'm using the K-means algorithm to divide my data into 3 distinct groups or clusters. The n_clusters equals 3 feet tells the algorithm to aim for precisely 3 clusters in the final grouping. This score tells me how well separated my clusters are. A score of 0.45 means the clusters are reasonably well separated, but not perfect. It's a moderate score, closer to 1 would be better. This index measures the overlap between my clusters. A score of 0.8 indicates substantial overlap. Not good. Lower scores are preferable here. I need to determine which statements accurately reflect how good my clustering is, based on these 2 scores. This is incorrect because the Davies-Bouldin index shows significant overlap between the clusters. My clustering isn't excellent. The Davies-Bouldin index supports this. However, the silhouette score suggests it's not entirely terrible. So, this statement is too absolute. This is the correct answer. It accurately reflects the conflicting information. One score shows reasonably good separation, while the other indicates considerable overlap. This question asks you to assess the quality of a K-means clustering result using 2 common metrics: the silhouette score and the Davies-Bouldin index. I'll guide you through how to interpret these metrics. This statement is too strong. While a silhouette score of 0.45 suggests reasonably good separation, the Davies-Bouldin index of 0.8 indicates significant overlap, making excellent an inaccurate description. This statement is partially correct. The high Davies-Bouldin index points to considerable overlap. However, the silhouette score isn't completely negative. It suggests some degree of separation. Therefore, the statement is too absolute. This statement accurately reflects the situation. I see that the silhouette score, 0.45, indicates moderately good clustering, while the Davies-Bouldin index, 0.8, suggests poor clustering. The conflicting results show the importance of considering multiple metrics. That's a subjective statement. There's no universally better metric. Both offer valuable insights, and interpreting them together is essential for a complete understanding of the clustering results. I'm working with a dataset containing 1,000 data points, each described by 5 different characteristics or features. Think of it like describing 1,000 people based on their height, weight, age, shoe size, and income. I've decided to group these 1,000 data points into 3 separate clusters using the K-means clustering algorithm. The algorithm will automatically group similar data points together. The silhouette score is a measure of how well separated my clusters are. A score of 0.45 is moderately good. It suggests that the clusters are reasonably distinct, but not exceptionally well separated. It's like saying the groups are pretty distinct, but there might still be some overlap. The Davies-Bouldin index is another way of evaluating cluster separation. A lower score is better. 0.8 is relatively high, indicating that there's considerable overlap between the clusters. It means the clusters are not well separated, and there's significant mixing between them. It's as if the groups are pretty much mixed together. I'm using K-means, a popular clustering algorithm in machine learning, to group my data points. I'm evaluating how good this clustering is using 2 different metrics: the silhouette score and the Davies-Bouldin index. Now that I have the scores, I need to determine which statement best describes the quality of my clustering based on these indices. We're evaluating how good a K-means clustering algorithm performed. K-means is a popular method to group similar data points together. Think of it like sorting socks. K-means tries to put similar socks into the same drawer. I have 1,000 data points, each described by 5 different characteristics or features. Imagine each point as a different sock, and each feature as a property like color, size, material, etc. I use the K-means algorithm to group these 1,000 data points into 3 clusters: like putting the socks into 3 different drawers. The in_clusters equals 3 feet part tells the algorithm to aim for exactly 3 groups. This score, ranging from -1 to 1, tells me how well separated my clusters are. A score of 0.45 is decent, not great, not terrible. It suggests that most points are reasonably well grouped, but there might be some overlap or ambiguity. This index measures cluster overlap. Lower scores are better. An index of 0.8 is quite high, indicating significant overlap between my clusters. This suggests that my 3 drawers might have quite a few socks that could just as easily go in another drawer. Let's evaluate which statements correctly reflect my clustering results based on the silhouette score and Davies-Bouldin index. I will analyze each option individually. This is wrong because one metric suggests reasonable clustering while the other suggests poor clustering. Hence, it's not excellent. This is partially true because the Davies-Bouldin index indicates significant overlap. However, the silhouette score isn't entirely negative. This is the correct answer. It accurately summarizes my results. One metric says the clustering is reasonably good, and the other says it is poor. This perfectly describes my situation. This is subjective. Both are valuable. Each highlights different aspects of the clustering results. Neither metric is universally better than the other. I'm evaluating the quality of a K-means clustering result. K-means is a popular algorithm for grouping similar data points. This evaluation focuses on how well the algorithm separated the data into distinct clusters. I'm working with a dataset containing 1,000 individual data points. Each data point is described by 5 different characteristics or features. Think of it like describing a person with 5 characteristics: height, weight, age, shoe size and hair color. I've applied the K-means algorithm to this dataset, instructing it to find 3 distinct groups or clusters within the data. The in_clusters equals 3 feet part specifies the number of clusters I want the algorithm to create. The silhouette score is 0.45. This score measures how similar a data point is to its own cluster compared to other clusters. A higher score means better defined clusters. 0.45 suggests a moderately good clustering, but not perfect. It's like a test grade. 0.45 is a passing grade, but not an A+. The Davies-Bouldin index is 0.8. This measures the average similarity between each cluster and its nearest neighbor. Lower scores are better. 0.8 is relatively high, indicating substantial overlap between the clusters and poor separation. A lower score would mean the clusters are better separated. I need to determine which of the given statements accurately reflect the quality of my clustering based on the silhouette and Davies-Bouldin index scores I've calculated. This is incorrect. While the silhouette score is moderately good, the Davies-Bouldin index shows poor clustering. Excellent is too strong a claim given the results. Partially correct. The Davies-Bouldin index shows poor clustering, but the silhouette score isn't entirely negative. The statement is too absolute. This statement is correct. It accurately describes the conflicting information provided by the 2 metrics. It's important to consider multiple metrics when evaluating clustering quality. This is subjective and not necessarily true. Both metrics offer valuable insights, and neither is universally superior. The best approach is to consider both. I'm evaluating the quality of a K-means clustering result. K-means is a popular algorithm that groups similar data points together. This evaluation focuses on how well the algorithm did its job. I'm working with a dataset containing 1,000 individual data points. Each data point is described by 5 different characteristics or features. Think of it like describing a person with 5 attributes: height, weight, age, shoe size and hair color. Each data point is a person, with the 5 attributes as the features. I used the K-means algorithm to group these 1,000 data points into 3 distinct clusters. The in_clusters equals 3 feet part means I told the algorithm to find 3 groups. The silhouette score is a metric that tells me how good the clustering is. A score of 0.45 indicates a reasonably good, but not perfect, clustering. The closer the score is to 1, the better the clustering. Values near 0 mean the clusters are overlapping. The Davies-Bouldin index measures cluster separation. A lower score is better. A score of 0.8 is relatively high, meaning the clusters are not well separated. There is a considerable amount of overlap. I need to determine which statement correctly describes the quality of the clustering based on these two scores. Let's analyze each option. This is incorrect. The Davies-Bouldin index shows significant overlap. While the silhouette score isn't terrible, it's far from excellent. Partially correct. The high Davies-Bouldin index points to significant overlap between the clusters. However, the silhouette score isn't entirely negative. This is the correct statement. It accurately reflects the conflicting information. The silhouette score suggests the clustering is moderately good, while the Davies-Bouldin index shows poor separation between the clusters. This is subjective. Both metrics provide valuable information, and neither one is universally better than the other. We need to consider both to get a complete picture. I'm evaluating the quality of a K-means clustering result. K-means is a popular algorithm that groups similar data points together. This evaluation helps me understand how good the groupings are. I'm working with a dataset containing 1,000 individual data points. Each data point has 5 characteristics or features that I'm using to group similar points together. I used the K-means algorithm and told it to create 3 separate groups or clusters from the data. The _n_ clusters equals 3 part means I've specified that I want 3 final clusters. The silhouette score measures how well each data point fits in its assigned cluster. A score of 0.45 is pretty decent. It suggests the clusters are reasonably well separated, but not perfect. It's like saying a pizza slice fits in its box pretty okay. The Davies-Bouldin index measures the overlap between clusters. A score of 0.8 is relatively high, suggesting significant overlap. This means the clusters are quite messy and not well separated. I need to choose the statement that correctly interprets these two scores. It is a multiple-choice question based on the analysis. This is incorrect. While the silhouette score is okay, the Davies-Bouldin index clearly shows overlap. I'm looking for a more nuanced answer. This is partially correct but overly simplistic. The Davies-Bouldin score supports this, but the silhouette score indicates better results than this statement suggests. This statement is too general. This is the correct answer. This statement accurately reflects the mixed messages from both scores. It's perfect. This is subjective and not necessarily true. Both scores give useful information, and their combination provides a more complete picture of the clustering quality.